That's not really enough to be successful in this. So please to pay attention. Also, you may have noticed that there are actually some grades in the grade book now, which means that if you have not done those, they are late, which means in order to get them graded, you need to fill out the late work resubmission form, which is right here. Please don't submit this form if you haven't actually done the work. It is frustrating enough to have to go back and grade people's work a second time, but to go through it and find that it wasn't done yet because whoever just filled out the form and hoped I wouldn't check or something, that is extra frustrating. Okay, and pretty sure everyone has had more than enough time to get the work done that I have graded. And I think it's only up through lesson 7 that I've graded. If you haven't done lesson 8, please do it. Way too many people hadn't done it. I was going to grade it, but I'll give you another day or so before I start grading lesson 8, which was due a week ago. So get on it. Okay, so what else do I need? I have all this. All right, lesson 11 bubble 4 is where we left off. Let me go back and get to my account. So we are still working on traversals, going through an array and doing a loop, doing the same thing to every item in the array, no matter how long it is. We can do lots of different things, and that's sort of the point. For this one, we get a list of animals and called animals. It's a good name for it. And our goal is to, well, what they give us is a loop that will go through each one of these strings and figure out whether or not the length of that string is greater than 5. Now, so we have first we have our list filled with strings. They also give us an empty list called animals filtered. And this loop goes to each one of these strings and checks to see if its length property, remember lists have a length property, but so that's how many items are in that array, and strings have a length property. It's how many characters are in that string. It goes through each string in the list and checks to see if it has more than 5 characters. If it's true, if this conditional is true, it gets it adds to the filtered list whatever one we're looking at. Now, this code has what I would call a useless, pointless variable here, this sort of one use situation. You wouldn't do this like intermediate step where you have a variable called animal that just receives whichever one we're looking at is used in the conditional and used in the append item. You would just have, if animals at index I dot length is greater than 5, then append to the filtered list animals at index I. You don't need to change this, but this is what the format, and then you don't need that. Okay. And when you have all these square brackets, sometimes it's easier to look at in text mode. Maybe not. That's a lot of parentheses. But let me get rid of this one. There we go. So if animals at index I dot length, because when you say the name of a list and an index, which in this case I is our index, because it's looping through and I is changing each time, so we look at each item one at a time. When you say the name of a list and an index, you're just referring to what's in that list the way we would access what's in a variable. And because it's a string, it has a dot length property. And if dot length is greater than 5, we append to the list called the filtered list whatever it is we're looking at, animals at index I. And we'll see later, it doesn't always have to be the list we're looking at, but it will always be the index we're looking at, because sometimes you have 2 lists running parallel or figuratively parallel, and you check what's in position 2 of the first list. And if that's something that you want, you get the thing in position 2 of the other list because they correspond. Here, we only have one list to worry about. And that's why when we run it, we go through and we get all of the strings with more than 5 characters put into the filtered list. And then we console log the filtered list. That's what's going on there. Okay, for the other one, and the one that we're supposed to do on our own, I'm going to get rid of what's already there because it's unnecessary, and get rid of the temporary variable thing. All we need to do is loop through, or do a loop. How many times do we want to do the loop? We want to do it students.length number of times. And every time through the loop, we want to do a conditional. What is our conditional? Well, our conditional is if, we already have an if students at index I dot length is 6 or more, so greater than or equal to 6, we want to append it, append item. The list we want to append to is students filtered, and the thing we want to append is students at index I. And we run now, we'll get all of the names which have 6 or more. Not too hard. All right, level 5. Sure, take a pass. Level 5, we have a list of numbers. And then we have, all right, so what's going on here is we are creating, or they've given us a loop here that is finding the lowest number in our list. This is a very common situation, and it's sort of a real basic form of sorting. And the way it works is, the general idea is you start with the first item. And well, first of all, you need a container to keep track of whatever you're looking for, in this case, the lowest number. You give that container the first item in the list, and you go through each item in the list, and if the item you're looking at is lower than your running champion for lowest, you put that new lower number in the container, and then you take that and go to the next one. And if the number you're looking at is higher than the lowest one you're looking for, you skip it, or you just go to the next one. If it's lower, you then put that new lower number in the container, and by the end, you've only kept the lowest number of all the numbers. Now, it doesn't tell you where in the list it is. It doesn't tell you whether it was duplicated. It doesn't tell you whether or not all the items are the exact same number. It just tells you the lowest number in the list. And it's doing that thing again where it has like this temporary variable, which is not necessary. So it would be, we go through the entire prices list, and if prices at index I is less than minimum price gets prices at index I. Okay, this is a little verbose, or I don't know how you describe it, linguistically, but if prices at index I, which is the thing the next one we're looking at, is lower than our running champion for lowest, the container holding the number that is our lowest number gets whatever one we're looking at. And as we go through, when we get to the end, we will have the lowest one. Now, normally when we start an empty variable, we would start it with 0, just because it's a number and we'll give it the properties of a number and declare and initialize and whatever. The problem is, if you just give it 0, it will return 0 as the lowest price, and 0 is not on the list. So the way you prevent getting a result that isn't on the list, which obviously it can't be the lowest number if it's not on the list, the way you prevent getting a number that isn't on the list is you give that you give that variable the first thing on the list. because the first thing on the list might not be the lowest, but it could be. So that way it wouldn't be wrong. You just give it the first item, which as long as the list isn't empty, there's going to be something in the first position, meaning index 0. So you just give it that first thing, and then you take that number, and technically it compares that number against the first number on the list, which it is. So there's like one redundant step, but it's better than any other way. And by the time it gets to the end, we have whatever number was the lowest overall. Okay, for the other one where we are looking for maximum price, I'm going to delete all this because it gets in the way. We are going to go through the price. We have the same prices list, and we have a new variable, max price, and it is given the first item in the prices list, the first number. Now we need to go through each item in the prices list and check, meaning if statement, if the thing we're looking at in the prices list, prices at index I, is we're looking for max greater than max price, then we need to reassign the variable max price to whatever we're looking at, prices at index I. And when we get to the end, we will just go through each one and keep whatever number is the highest. By the time we get to the end, we will have the highest one. That's it for that one. All right, so I don't think we've done that much with the data set before, or the data tab, but App Lab has a ton of data for you to use, a ton of data charts. Is that what they're calling them? Yeah. And this is great because it allows us to test and work with traversals in it with a meaningful data set, a large enough data set where it actually makes sense to write program to sort. Before we just had to like make our own lists full of nothing and sort through them, but this is a lot better. And I can't remember if we talked how much about it before, but the idea is you need to, well, first, out of all the lists here, which you should take a look through because you're going to choose one of them for your end of unit project, and you take a look at it and you see what actual columns it has, because what you're going to do is import, well, you have to import the table into your program, but once it's imported, you get column, which returns everything in the column as an array. And what's interesting about that is if you have two columns, you know whatever is in index, well, it's the second item on the list, index 1 in artist column corresponds to whatever is in the index 1 in album column, whatever is in index 1 in year column, and so on. And that's, you know, unlocks all of being able to access all that data really easily. So here is what I was talking before about having two lists run in parallel, which is what I was explaining. And what we get here is the full list of states and a list called year list, which is the year whichever state was admitted to the union. And so, yeah, so state names is just one for each state. And then admission year is the year that was, that state was admitted. And you use the get column command. You set up an empty variable. You're declaring var name what you're going to name that list, and then get column. And that creates the computer interprets that as an array. Okay, which you can see if we did console.log state list and look at what comes out at the bottom, or the first thing that comes out because there's other stuff still there. We get a list. You know, it's a list because it has square brackets, items separated by comma, and they're numbered, you know, 0 to 49, of course. So we can now use this states list as our array for sorting. It's doing the same thing again, where it's making these sort of pointless variables. I'm going to sort it around the way you would actually see it. And which is like that. I don't think that confusion, that extra line of code cleared up any confusion, but we have a loop that goes through, it loops through the number of times that there are items in state list. State list or the main list doesn't have to be the number of times you do the loop, because state list and year list have the same number of items in it. The loop will run the same number of times. Every time through the loop, it checks to see if the number that's on the list called year list at whatever position we're looking at is a number greater than 1900. It gets the state at that same index, because while in the loop, I is going to be the same number. Next time through the loop, I goes up by 1, but the entire time through the loop that time, I is the same number. So we're checking every item in year list, and if that number in year list is greater than 1900, we get the string or the state name in state list at that same position and append it to our already made, ready to receive filtered information list with the append item, and then it prints it out or logs it here, all the states with that were made after 1900. And we need to do the same thing for the other portion, which is a population situation. I'm going to clear it out, which you don't need to. Okay, so we need to write the same thing again, but for population, and they've given us now the population list and an empty list ready to receive the filtered information. I'm going to get rid of these temporary one use or immediate use and dispose of variables, do it the regular way. So we already have our loop that's going to run once for every row in the column. And we want to go through the entire row of populations. And the entire list column of population values. And if they are greater than 1 million, or less than 1 million, we want to get the state name at that same position. So it's not while, it's if. If population list at index I, whichever one we're looking at, is less than 1 million, then we want to append to our empty or filter list called small population whatever is in state list at index I. And we don't need these. And when we get to the end, we will have a full list of states with less than 1 million people. Easy peasy. All right. So next one, bubble 7 has 3. And then there's just a simple check for understanding at the end. All right, so this one is a little bit more freeform than the previous ones, but not as freeform as the next ones. So we get here and we have a program that receives number inputs from the user. And I think when we get here, it actually it already works for receiving input. But the calculate average grade doesn't work, which is what we want to solve. We have an empty list, which is receiving the user's input every time they click the add grade button, and runs update screen, which just sets the text of this text area. Well, first of all, it clears out the text input, which is always nice. And then it sets our text output, our main text, to every item in the list, joined with a new line command in between, the .join command. All we need to do is write a program or write some code that will take all of the items in the list, add them together, and divide by however many items are in the list. That's how you get an average. An average is sum divided by total items. So the way we need to do that is, of course, we need to loop. And the number of times we need to loop is grade list.length. And what do we need to do to each item in the list? Well, in order to keep track of the total, we need to declare a variable before it starts, because if we declared it inside, it would get wiped every time through the loop. So how about we just call it sum, start at 0. That's a fine place to start it. Then every time through the list, every time through the loop, once per list, sum is going to get itself sum plus whatever is in the list at the position we're looking at. Grades list at index I. And once we have a sum of all the numbers, we can, I guess let's take a temporary variable. It'll be easier if we have more stuff. Let's have a new variable, average average. Let's just do it like this. We're declaring it with our little calculation. So average is going to get sum divided by grades list.length. Okay, and then we have average, which is what we want to print out here. And so we can just go ahead and do set text. We don't have to throw it. If we wanted to throw it to update screen, we would have to make this a global variable or pass it through as a parameter, which we don't really need. We can just do a set text right here and set text of average grade label. Yeah, average grade label to, and we're going to have to mess around with this. If we set it to just a average, when we run it and add a few numbers, we can then click average grade and it will set it to that number. Now, I want it to say, what does it say at the beginning? Your average grade. So let's concat that with average. So it's going to be open string, your average grade, close string plus average. So it will concat that. And now we add some numbers. And we click average grade, we get an average. Now, I don't want all these decimals. I want to round it. And in AppLab, we already get the math.round function or method, and that allows us to round. Now, in AppLab, math.round rounds it to a whole number with standard rounding practice. For real JavaScript, you can round to a specific number of decimals. It'd be nice if it wouldn't be hard for AppLab to add that. But in order to do that, we need to we need to round average. And instead of doing it in the concatenation, it needs to be done before we use it. So what we can do is just reassign average, AVG gets math.round of average. So it gets itself rounded. We could do it in this part, do math.round before we do sum divided by grades list.length. But that's kind of a pain with blocks, but it is how you would do it normally. And now when we run it, now average of 1 and 2 should be 1.5, but it rounds up. We in the next one are going to show, or maybe the last one, show how to do decimals. It's a kind of a workaround for the fact that math.round rounds to a whole number, but that's what we've done here. Now there's still one more issue, and the issue is that if the user clicks calculate average grade before there's anything in there, they haven't, irreparably damaged it, but let's just not let the user do that. And the way we're going to do that is we're going to put everything inside of our average button list inside of a conditional. So essentially protecting the user from that button if the list is empty. Okay, so we just need a conditional, and we need to put everything that was in this, or that still is, in this inside of that conditional. And what is our condition for letting it happen? Well, if grades list.length is greater than 0. Which means it won't work if the list is empty. So now we hit run and we click calculate average beforehand, and it prevents it from happening. And I think that's it for this one. All right, 7B. So this one is a little tricky because it has so much going on, but it's really the same thing like 7 separate times. So we're going to solve it for one of them and then just duplicate it. And the list, well, in order to have a clue of what's going on here, we need to look at the data table that it's referencing, and then we might have a clue. So it's already added air quality index. And the situation is that for every county from every state, I don't know if it's every county, but several counties from every state, whoever took a air quality reading a different number of days for each county. And for each day that it was taken, an air quality rating was taken, it was either ranked good, moderate, unhealthy for sensitive groups, unhealthy, very unhealthy, hazardous. And the problem is each state has a different number of counties, and each county's reading has a different number of readings. But that's not an issue for us because we are always going to do dot length to handle unknown lengths. And we know that total days with an average quality index rating is going to be the total of good days, moderate days, unhealthy, and so on. That allows us to calculate a percentage. So good days in Baldwin County, Alabama were 250 out of 269 days taken. Moderate were 19 out of 269, and then the rest for blank. So what we're getting is a column with the state name and a column for total days measured and a column for each of the ratings. So what we're going to do is let the user choose a day. And when they choose a day, we're going to go through the entire list of going to go through the entire list of states. And if the state that we're sorting through is whatever they selected, we go through all the number lists, all the total days, the good days, whatever, and add it to these already existing filtered lists. Now, the filtered lists have to be declared globally, meaning at the top, and blank, but every time we pick a new state, they need to be cleared out, which is why they are here also. So the second time through, first thing it does is delete whatever was filtered before, and then goes through and filters. So it is a little tricky, but by the time we get, and this is already written for you, by the time the user has, when the user chooses a new state, which is what activates the filtering, all of these filtered lists have the numbers only from whichever state was selected. And now that we have a set of filtered lists only from the state selected, we can then do our percentage situation. So when they click display, all of these numbers are zeroed out. Well, we have a variable to hold the value that's going to go in each of these, and they're zeroed out again every time through, or every time they click the button. And the loop is going through each of the lists and coming up with the sum of all the numbers for that state in each of the categories. Once we have a sum of all the numbers for each one, we can find the average by dividing the sum of this group divided by the total days measured, and the sum of this group or this list divided by the total days. All that is already done for you. We just have to find the average for each of those categories and then send it to the display. So let's do that. We need a output. Okay, we can just do the output here. Let's do a set text of, let's just go through the first one. The first one is called good output. Sure. Good output is going to get total good days divided by total days. Okay, and now we pick a state, we hit go, and we get a percentage. Now, clearly, if we're looking for a percentage, it's not going to be 0.67%. It's going to be 67%. So in order to get the correct output, we need to take whatever this is and multiply by 100. Pick a state, we hit go, and we get a percentage. Now, we get another decimal. So what we can do is just round this. And the easiest way to do this, let's see, we do it this way. Go in front of total good days, do math.round with a capital M. In fact, you can even do, click the drop down. It gives you an open close parentheses. What just happened? Oh, it's because I have a thing. Never mind. Math.round. And then open parentheses and go to the end, but inside the semicolon, close parentheses. This will do it. The other way to do it is to, can I get rid of that? No. The other way to do it is just to bring out a, whatever. You guys can figure out the parentheses situation. I'll pause it here so you can take a look. Where you put your open and close parentheses is super important. Okay, this last close parentheses technically belongs to the set text, but the line needs to end with two parentheses because one of them corresponds with this open parentheses and the other one corresponds with that one. So it's math.round of our division multiplied by 100. That will give us a whole number percentage. And go here and click, and there we go. Now, for the rest of them, it's actually going to be a lot quicker because we can copy and paste a bunch of stuff. So for the second one, it's called moderate output. Come on. Moderate output. And it's going to get moderate days divided by total. And I think I just need it to be smaller. And the next one is called unhealthy for groups days. Unhealthy for groups. Wait, no, is it labels or out? It's output is what we're looking for. Unhealthy for groups output is unhealthy for groups divided by total. And just to make sure we're not wasting our time, go ahead and test it to see if we get, there we go, excellent. And the next one is just unhealthy day, is unhealthy output. Unhealthy output is unhealthy days. Oh, everything's going so thorough slow. And then the next one is very unhealthy output. And that gets very unhealthy. And the last one is hazardous output. What did it do at that time? Hazardous output gets hazardous days divided by total, and now we hit run. And for any particular state, we get we get the percentage of days that fall into each one of those categories. Okay, little bit redundant stuff going on here, but it is still a pretty effective output for sorting that many rows and that many numbers. And I think that's where we're going to leave this one. Okay, and the last one is a little trickier. Or it's a little bit more complex. I guess that's another way of saying trickier. And let's see, does this one work when we're done? Or when I'm here? Is it actually working? Good. So the goal, and this one is where we're going to finish, is to sort through a table called US gas prices and find all the readings that correspond to a chosen year. And all the readings that correspond to that chosen year, average all their price readings for a particular state. Now, we aren't going to do city. We aren't going to do each one of them. We're just going to do one other than the one we start with, which the one we start with is just Seattle. But we need to we need to replicate all of the programming for Seattle for another one that's called Miami. And in order to figure out how this is going to work, we need to look at the data table and see how it's formatted. So the most important thing to take away from looking at this is that the column for date, which is the one we're using to sort for year, the column for date is a bunch of strings. Well, each entry is a string. Even though it's all numbers, it's wrapped in quotes and it has slashes. It has the properties of a string. It is a string. Now, if they had one column for month, one column for day, and one column for year, it would be a lot easier because we could just compare the user's year to the actual year or to the year from the table and get all of the information from that row. But because it's a string and because it's a string, we need to do substring, which we've done before. And substring is just like finding an item in a list, okay? Index 0 and 1, 2, whatever. So we would pick index like 5 through 9. The problem is some dates have 2 digits for the month, some have 1, some have 2 digits for the day, some have 1. So we can't count from the front in order to get to the year. We can, however, count from the back to get the year. So when we look at the date, we need to separate the last 4 digits. So it's going to be a substring starting from the end minus 4 and ending at the end. That will give us a substring that is the year of whatever reading. And we're going to go through the entire list of dates, and each row that has the year we're looking for, we can go over to the column or the city column and add that to a list, a filtered list for that city, and do the same thing, finding the average, sum divided by however many there are. Now, we don't know how many there are for each year, partly because it starts in May for the first year. So again, we need to do a list.length number of loops, which we would do anyway. And so let's work through it. So let's see how they did Seattle. Well, they bring in both the date column and the list of measurements, list of readings. Why can't I get over there? For Seattle, which is just a bunch of numbers, so it has number properties. And it has an empty list for filtered Seattle. When the user clicks on the dropdown, first thing is it clears out that filtered list so that we can get the numbers from a different year. It runs filter, and then it runs Seattle average. Filter goes through the entire list of years, picks out the last 4 digits, or the last 4 characters for each of the dates, puts them into a very temporary one-use variable called year. And if that variable, which is the last 4 characters, is the same as the dropdown that the user took or chose, we go and get the number from the Seattle list, put it in filtered Seattle. Then when this is done, we will have a list of all of the numbers from the Seattle column from the year the user chose. Once we have that list, we can then do the averaging situation, sum divided by, or sum divided by total. So we need to set up the same thing for Miami. Let's go ahead and do a list. We'll just call it Miami. We know it's the prices from Miami. We don't have to say Miami prices. And we need a filtered list ready to receive those Miami prices. And that filtered list needs to get wiped out every time we do a new filtering. So we wipe the filtered list. We only need to run filter once, but every time through, we need to go through, well, we're only going through the year list. And if the year matches the user year, we're getting the price in that same position, the Seattle list. We want to get the price in the same position of the Miami list and add it to our filtered list. Miami, filtered Miami gets Miami at index I. And so when we're done with this, we will have all of the items from the Miami list from the year chosen, all of the numbers. We then need to do the average of Miami. So we'll do Miami average. And so we are calling a function that doesn't exist yet, which is always like a power move. So we're calling Miami average, which doesn't exist yet. So we need to go and write that function. And I just want some more white space so I can look in the middle of the screen. And so we are writing Miami average. And how do we do an average without looking at the Seattle one? Any average, we are going to need to add up. First thing we do is add up all the numbers in the list. So let's just call it sum, starts out at 0. Loop through the entire filtered Miami list. So filtered Miami.length. And every time through, sum is going to get itself plus whatever we're looking at. Sum gets sum plus filtered Miami. And then we are going to output an average. So let's just call that variable average. And it's going to be sum divided by filtered Miami.length. Okay, the sum of all the numbers divided by how many there are. And when we're done, we will have the average. We can just do a set text. Now, this is not going to be finished. The set Miami label. Miami label. And we'll set it to average. And if we run it now, we choose a year. And we get not a number. What is going on? Filtered Miami. Did I typo somewhere? Average gets some. Okay, so I've got a typo somewhere. Let's do some console logging. Let's see. What is it? Well, I don't think average is going to look right. Let's try. Let's see what average gets. Okay, no number. What does sum get at this point? Okay, so sum is coming out as a string. No, it's sum. Oh, no, it doesn't get filtered Miami. It gets filtered Miami at index I, the thing we're looking at. There we go. So then we should be able to divide it since it's going to be, there we go. All right, so when we're done at this point, we get just a long decimal, which is not what we want. First of all, let's concat beforehand the word Miami. With that average, so we can at least have the same format. And there we go. And we have a long number. So let's round it. Now, we could do, because average is our output, we could do math.round in this long, like in math.round, open parentheses, sum divided by filtered Miami.length, close parentheses. But sometimes I think it's cleaner just to keep updating the variable with whatever change you want. So we can do average gets sum divided by filtered Miami.length. And then average gets math.round of average. Okay, so we're updating average to itself rounded. You'll take a look at that. And this is pretty useless because when we talk about gas prices, rounding to the whole dollar is not what we're looking for. So the workaround for AppLab is to multiply something by 100 and so the workaround is to multiply by 100, round that number, and then divide by 100. So you move the decimal place over 2, round it, and then move the decimal place back over 2. That gives you 2 decimal places of rounding. So before we round, we need to multiply it by 100 before the rounding takes place. So we are going to update average to get average times 100. We then round it, and then we need to back it out again. So average is going to get average divided by 100. And then we should have 2 decimal places of fun. There we go. And you could argue divide it by, or have it 3 decimal places, because gas prices are actually in 3 decimal places. And if you notice the and 9/10 at the end of every gas price, which I think is just sort of like really disingenuous. But there we go. I think 2 decimal places is fine for this. We aren't going to do each of them, each of the cities, even though I think this is a really interesting format of, or yeah, design, layout, graphic design for these labels on top of a map. I don't know. I find it aesthetically pleasing. The problem is, in order to do each one of those, we need to do what we just did over and over again. You would think that there is an easier way to do this, considering we're doing the same thing over and over again. Like we would want to do it for each city, but there isn't really in this context. So you can if you want to, but if you have just Seattle and Miami, or Seattle and one other city, it doesn't matter, as your output, that will be fine. All right, and then the last one is just a check for understanding that we can do together. And it's another pseudocode, super fun situation that we can just work through. It's a basic loop situation. And as always, it's super easy if you just keep track of the different values as you walk through it. Let's see, does this work? Yeah, okay. So we are given a list called student scores, which is 5 numbers long. And we have a blank list called updated scores. And our goal is to figure out what the value of updated scores is when we're done, or what the list contains. So we are just going to keep track of the list here. Okay. We don't use a for each loop in AppLab, but a for each loop is the same thing as a for loop done the list.length number of times. So to each item in the list, run this bit of code. So a lot of the pseudocode, even if you haven't seen it before, if you just sort of read it in English, it will probably make sense. So for each item in student scores, check to see if that item is greater than 60. If it is greater than 60, add an item to updated scores, update or add that item plus 5. If it's not over 60, the else, add a 0 to the end of the list. So we're going to go through each one of these items and check to see if they're over 60. First one, 77. Is it over 60? It is. So to the end of the list, we add 77 plus 5, 82. Next item in the list is 32 over 60. It's not. Append a 0. 45 is 45 over 60. It's not. Append a 0. 92 is 92 over 60. It is. So append 92 plus 5. And the last one is 86 over 60. It is. Append 86 plus 5. So this is what the result of that code does. I think you'd get more out of working through it or watching me work through it than, just guessing and waiting for that sound to happen. But that is it for lesson 11. We are going to do 12 next time, I think. See you guys Thursday. Yes, probably. All right. So yeah, let me know if you have any questions. There's really no excuse for falling behind, considering everything is available.